Okay, the new section is entitled Solving Systems of Linear Equations using the elimination method. So we're going to have two differential equations and we want to solve them simultaneously. So suppose you were given that dx dt is equal to 4x plus 7y and that dy dt is equal to x take away 2y. First thing we want to do is write this using differential operators. And to get everything but the constant on one side of the equation. So I'm going to bring this term and that term over. So I'm going to get dx dt minus 4x minus 7y is 0. And of course, dx dt is just x prime. Same deal with the second equation. dy dt is y prime. And I'm going to bring these two non-constant terms over. We're going to go over as negative x plus 2y. In fact, I'd rather write the negative x first. You'll see why in the next step. So I bring the x over as negative x. The dy dt, which is y prime, stays there. And the negative 2y goes over as plus 2y. And now the right-hand side is 0. Now, just to make it clear, when we have dx dt, that means x is a function of t, and you're taking a derivative of x of t. That is, dx dt is really x of t prime. Just like dy dx is really y as a function of x prime. And another name for, let's just write it there. Another name, well there's the of x. Another name for y is x. And you want the derivative. The x and y are functions of t. Same argument how I said that this means x is a function of t. This means y is a function of t. Okay, now maybe I'll put it here. I want to write what I have in the right column using differential operators. So I'm going to isolate the x's and the y's. The x's and the y's. And then I can use differential operators. Okay, so it's going to be b minus 4 operated on x. Because if you take the derivative of x, you get this minus 4 times x. So that's the first part of the equation. Minus, well, 7 is an operator, and it's multiplied by y equals 0. The second equation, looks like maybe I wrote it down wrong. Okay. Everything's fine except where I put my brackets. Okay, so let's just rewrite. It's negative x plus y prime plus 2y. So the negative x is negative 1x, and that's this piece. And this here is d plus 2 operated on y. If you take the derivative of y, you get y prime. And if you add on 2y, well, you're adding on 2y. And just like it says on the right side of the equation, it equals 0. So these are my two equations that I'm going to solve. Now, We're gonna do it just like we did before in high school algebra, except the coefficients of x and y are not real numbers. They're differential operators. But nonetheless, we do it the same way. If you have b minus 4x and you have 1x, well, if I just multiply this by b minus 4, then these two will be equal. So I'm not going to do anything to the first equation. And I'm going to do b minus 4 or negative x plus b minus 4 on b plus 2 of y. And I'm also going to do b minus 4 of 0. Well, the derivative of 0 is 0 minus, and 4 times 0 is 0, so I still get 0. Now, if I add these, this will cancel out. I add the y's. I have b minus 4 times b plus 2y's, and I'm adding negative 7y. Adding negative 7y is the same as taking away 7y. So we have that. Let's clean this up a little bit. We're going to have d squared plus 2d minus 4d is negative 2d minus 8 minus 7 more is minus 15. So the auxiliary equation will be this. When two numbers are multiplied up to 5 and add up to negative 2, well, they go next to the ends. Add up to negative 15, excuse me. Multiply to negative 15. Those numbers are going to be negative 5 and plus 3. So m equals 5 is one solution, and negative 3 is the other. So the homogeneous solution, y of t, will be c1 e to the negative 3t plus c2 e to the 5t. Let's write that up here. Y homogeneous, c1 e to the negative 3t plus c2 e to the 5t. And what we've done was we eliminated x. We got rid of x. Now we're going to do this all over again. I'm going to get rid of y. Now we want to get rid of y. So we have 7y and b plus 2y. The common multiple will be 7 times b plus 2y. That is, I multiply this top one by b plus 2 and the bottom one by 7, and everything will be fine. I have to do that to the whole equation. I need to multiply this term by d plus 2, this term by d plus 2, and that term by d plus 2. So I get d plus 2 composed with b minus 4 on x minus 7 times d plus 2 on y. It's going to be 0. So if we do d plus 2 of 0, we're going to get the derivative of 0, which is 0, plus 2 times 0 is 0. You're going to get 0. Any differential operator on 0 will give you 0. And for the second equation, I'm going to multiply by 7. Going to multiply by 7. When I multiply this term by 7, I'll get negative 7x. Plus, says plus. When I multiply this by 7, I'll get 7 times b plus 2y. Multiply 0 by 7, I get 0. Now, these two terms are exactly alike. Almost. One is negative, one you're taking away, one you're adding. Well, if you add these two, they'll vanish. You have to add everything. For example, I'll add the 2 zeros on the right side. And on the left side, I'll have d plus 2 times d minus 4 minus 7 x's. I just backed it out to x. This is d squared minus 4d plus 2d is minus 2d minus 8 minus 7 more is minus 15. And you get n squared minus 2n minus 15 is 0, just like before. And you have n minus 5, n plus 2. Of course, n plus 3, excuse me. And so m is 5, or m is negative 3, and you get that x homogeneous of t is going to be, since I use C1 and C2, I'll say C3, e to the negative 3t plus C4, e to the 5t. So I got 5. So x homogeneous is C3, e to the negative 3t plus C4, e to the 5t. So we have that. We have the homogeneous solutions. But you know what? That's not bad, because they were homogeneous equations. That is, I didn't just say it equals 0 even when it said t squared plus 4. It always equals 0. So now, there's our solution. However, there's a connection. So right now, the constants are C1, C2, C3, and C4. And there's connections between the two. That is, maybe C1 is 2C3. Maybe C2 is negative 5C4. That is, I can get rid of C1 by writing that. So no more C1. You don't have C1 here anymore. You don't have C1 here. So say that C1 I wrote as 2C3. Same thing with C2. The only C2 I see is right there, and it's no longer there anymore, because I'm going to write C4. Okay, so here I have C3, here I have C4. The C1 is really C multiple of C3, and C2 is a multiple of C4. That is, I can write x and y just using two unknowns, two constants. So how do I find a relationship like this? The answer is you plug it back into one of their original equations. The original equations were dx dt plus 4x plus 7y. The other one was this. I would use the one that has the least number of derivatives. Like if this one down here said the second derivative, I would most certainly use the first one. Okay, one little typo, that should say equal. Another typo is what I just put in for an example. They both look equally as difficult. In fact, I'll use the bottom one only because the numbers are smaller. You don't have to multiply x by anything like you do up here. And here you just have to double y, not multiply it by 7. So what I get is x prime, bring that over, minus x plus 2y is supposed to equal 0. And I'm going to use the x and y at the very, very top to do this. So first I need to know x prime. Well, x prime will be, I'm looking up here, be negative 3 c3 e to the negative 3t plus 5c4 e to the 5t. I need to take away x. So minus x, well that's x, I'll do minus x. Minus c3 e to the minus 3t minus c4 e to the 5t. And I have to add on 2y. So I double y. I get 2c1 e to the negative 3t plus 2c2 e to the 5t. And when I add up the left-hand side, which will be this, I'm going to get what it equals. Equals 0. Okay? Now, everything I did was real nice. That is, everything's lined up. Those are multiples of e to the negative 3t. I have negative 3 c3s, and I'm taking away another one. So that gives me negative 4 c3s, and I'm adding on 2 c1s. That is how many e to the negative 3t's I have. Plus, I have, these are all e to the 5t's. I have 5c to the 4, and I'm taking away 1c to the 4. There are 4c to the 4, plus the 2c sub 2's. And this is e to the 5t. How to get this to be 0 is just let these be 0. So let those be 0s, we're okay. Since I can divide each by 2, I'll say negative 2 c3s plus c1 is 0. And after all, if you just wrote this, I can divide every term by 2, and I get that one. I'm going to do the same thing here. That equals 0. Dividing by 2, I get almost that. I get 2c4 plus c2 is 0. And this is where I get my relations from. I'll just solve for c1. That is, I'll bring this to the other side. c1 is 2c3s. I'll bring that to the other side. c2 is negative 2c4. Okay, and now I'll copy down the top two equations, these two equations, and I'll put in these substitutions and I'll be done. X of t, excuse me, is c3 e to the negative 3t plus c4 e to the 5t. And y of t is c1, but that's 2c3 e to the negative 3t plus c2, which is negative 2c4, negative 2c4 e to the 5t. And these are the general solutions to x and t. Now, you have to be careful. You can say, oh, 2 times a constant, I can just 2 times c sub 3, I'll just call that c sub 3. No. This constant can be anything. What you multiply e to the negative 3t by for the x equation can be any number you want, but it can't be any number for y. It has to be 2 times what you put in front of e to the negative 3t. If you had 6 e to the negative 3t, well, over here, you better have 2 times that, e to the negative 3t. Similar argument for the e to the 5t. You can multiply e to the 5t by any constant you want, any constant. But once you pick that constant for x, for the x function, you can pick any value you want to multiply e to the 5t by, any. But when it comes to the y function, you better take away twice what you put here. If you put 5 there, you better take away 10 over here. And at the very bottom, that's the solution to this problem. As always, let's do some more. Learn by doing examples. Here we have, let me write it down. Here we have dx dt minus 4y is 1, and dy dt plus x is 2. Well, remember that dx dt is just x prime minus 4y is 1. Notice constants on the right side, everything else on the left. Y prime is, dy dt is just y prime plus x is equal to 2. So I'm going to just write the x's first. I'm going to say x plus y prime. Now, I'm just going to rewrite this one more time. That is, first I had this, I wrote it like this. I'm going to do it one more time. This is, I'm going to use differential operators. D prime is just d operated on x minus 4 operated on y, if you like, equals 1. X is just x, or 1x, plus y prime. There's the plus. Y prime is d operated on y, and this equals 2. Okay. So now I have my two equations written as differential operators. And I go and I solve this. I want to get what's in front of the x's to be the same. So what I'm going to do is I'm going to take d of both sides. The top will just be d operated on x minus 4 operated on y equal 1. D times 1 is dx. And now we have d squared, the second derivative. Take the derivative, remember d, dy. It means d of y. So the d I just wrote here is that d. And what's in the bracket will be what this is equal to. Well, the derivative of y is y prime. And the derivative of y prime is the second derivative. And the derivative of 2 is 0. Now, if I happen to subtract these, what's going to happen is this cancels. But I hate writing a negative term first. It's just my style. I just don't want to write a negative term twice. First. So I'm going to do the bottom minus the top. So we have positive d squared y minus 4y. I just backed it out for y. This is going to be negative 1. So 0 minus 1 is negative 1. So auxiliary equation will simply be n squared minus 4 equals 0. Well, you should know that must be 4. Excuse me. If you have b squared, which I wrote down, and you take away a negative 4, that is the same as adding 4. So this should be negative 4. Negative 4 plus 4 is 0. The hardest looking part, you see blank. What plus 4 is 0? Negative 4. So m squared is negative 4. The m is going to be plus or minus the square root of that number, which is 2y. So let's see. y homogeneous is going to be c1 cosine of 2t. Use just a little bit more space. Maybe plus c2 sine of 2t. Maybe c1 cosine 2t plus c2 sine of 2t. That is what y homogeneous is going to be. So we eliminated x and we found out what y was. Now, y homogeneous. Now, why is this homogeneous? Because I'm replacing that with 0. So it's not y particular because the right hand side is negative 1. So now we're going to do this all over again, but this time we're going to eliminate y. We're going to eliminate y. To get what's in front, if you have 4y, and notice I never ever care about the sign, whether it's plus 4y or negative 4y. To get what's in front of the 4y and the dy without erasing anything, to get them to look alike, I could erase the 4 and I can put a d there. You can't do that. You can only put things in, you can't erase. Well, I put a d on the top and a 4 on the bottom, now they look the same. You multiply the top by d. And I'm going to do d of that, and I'll get d squared x minus, I'm going to multiply that by d, and when I multiply that by d, that is when I take the derivative of 1 and get 0. In the bottom, I multiply by 4. I'm going to get 4x plus the derivative plus 4 times the derivative of y equals, I guess that doesn't belong there. Now I multiply the right side by 2 and I'll get 8. So these are my two equations. These are exactly alike. One we're taking away, one we're adding. So if you add them, they cancel out. You have positive 3 and negative 3 and you want 0. These numbers just differ by signs, you add them. If they're exactly the same, then you subtract to get 0. If two numbers just differ by signs, you want 0, add them. If the two numbers are exactly the same, subtract and you'll get 0. So let's do this arithmetic. I did part of it. I crossed out what cancel. Here you'll get d squared plus 4 operated on x equals 8. Now the auxiliary equation will become this. then this must be negative 4, and like before, and will be plus or minus 2y. So x homogeneous will be, I use C1 and C2 for y, so for x I'll start with C3. C3 cosine of 2t plus C4 sine of 2t. So x homogeneous will be C3 cosine of 2t plus C4 sine of 2t. Now, now we want to come up with a particular solution. We want to come up with a particular solution. Now, if you look at the right-hand side, you just have 1 and 2. In fact, one of our equations earlier was d squared plus 4 on y equals to negative 1. And for the record, the other one was, let's see, d squared plus 4 on x is 8. So let's work with the first one. If you want to take the second derivative of y and add on 4 times y, and you just want a constant like negative 1, you should think polynomial. You should think polynomial. You can say, well, y is ax squared plus bx plus c. That should be of high enough degree. Of course, a and b are going to end up to be 0. I hope that's clear. Now, y prime is going to be 2ax plus b, and y double prime will be 2a. Now remember, this equation here really says y double prime plus 4y is negative 1. Excuse me. So I have y prime on the last line, and I'll put down 4 times y. So I just multiply in this by 4, and I'll get 4ax squared plus 4bx plus 4c. Now, I'll add these two. When I add the left side, believe it or not, I get negative 1. After all, it said this. It said the second derivative plus 4y equals negative 1. When I add the right side, I get 4ax squared. I get 4bx's. And when it comes to the constant, I get 4c plus 2a. That's my constant. Now remember, it equals negative 1. Well, negative 1 is 0x squared plus 0x's minus 1. You equate. The 4a should be 0. 4 times a is 0. Well, I know one thing. If you multiply two numbers and you get 0, one of them is 0. And it isn't the 4. So it must be the a. And the 4b must equal 0. 4 times b is 0. Like I said above, for the reason above, b must be 0. And we have that the 4c plus the 2a is negative know a is 0, so it's as if that isn't there. 4c is negative 1, so c is negative a quarter. So updating this here, we have y is equal to 0x squared, which is 0, plus b times 0, getting zeros because a and b are 0. I have 0 plus 0 plus negative a quarter, which is negative a quarter. That is what y equals. That is y particular. Y particular is negative a quarter. Now, we do the same thing all over again for the d squared plus 4x equaling 0. That means the second derivative of x plus 4 times x must be 8. The second derivative of x plus 4 times x equals 8. So I'll say that x is a polynomial. Now we can say ax plus b even. So let's go to a square. Ax squared plus bx plus c. The first derivative, I'm going to go up to the second because that's what I need, is going to be 2ax plus b. And the second derivative will be 2a. So that's the second derivative, and I have to add on 4x's. Well, that's x, so I multiply it by 4. Get 4ax squared plus 4bx plus 4c. When I add the left-hand side, I get 8. How do I get 8? It told me x double prime plus 4x equals 8. When I add the right side, I'll add the x squared first, and there's only one term of them. I'll add the x's next, which is just that, and then I'll add the constants. It's 2a plus 4c, and it equals 8. Equals 8. That is, it's 0x squared, so 0x plus 8. So this must be 0, this must be 0, and this must be 8. Well, if 4a is 0, that means a is 0. If 4b is 0, that means b is 0. So those terms aren't really there for x. And I have that 2a plus 4c is 8. 2a plus 4c is 8. But a is 0. 2 times a is 0. You add 4c, you get 4c equals 8. So c is 2. Everyone knows that 4 times 2 is 8. Okay, so x of t is just 2. X particular of t is 2. So now we are in a position to write down the general solution. X general of t is going to be the particular solution of x plus the homogeneous, which is up there. C3 cosine of 2t plus C4 sine of 2t. And y sub g is going to be the particular solution, which is right here, negative 1/4, plus the homogeneous, C1 cosine of 2t plus C2 sine of 2t. And you could connect There are 4 unknowns. You can write 2 of them in terms of the other 2. That is what we are going to do right here. We're going to figure out how to connect the C1s to C4s. We can write them down just with 2 unknowns. Now, one of the original equations was, the 2 original equations were x prime minus 4y equals 1 and y prime plus x equals 2. So both of these equations is just taking derivative of x or y, and looking down here, one is not easier than the other. This one just adds x. This one takes away 4 times y. Who wants to multiply by 4? So I'm going to use the y prime plus x formula equals 2. Y prime plus x equals 2. So let's write down y prime. The derivative of the constant is 0. The derivative of positive c1 cosine 2t is negative 2c1 sine of 2t, plus the derivative of this will be 2c2 cosine of 2t. And then I add on x. 2 plus, just write these cosines under the other cosines, plus c3 cosine of 2t, plus, so that plus is correct, plus c4 sine of 2t. And when I add these, I'm supposed to get 2. Well, I do have a 2, and I have a number of sine of 2t's. I have positive c4, and I have to take away 2 c1s. That's how many sine of 2t's I have. How many cosine of 2t's do I have? Well, I have 2 c2's, and I'm adding c3's. That is how many cosine of 2t's I have. Well, if I let these be 0, then we have 2 plus 0 sine of 2t plus 0 times cosine of 2t, and regardless of what sine of 2t is, when you multiply it by 0, you get 0. So it's 2 plus 0 plus, and likewise over here, 0 times a number between negative 1 and positive 1 is going to be 0. So I do get 2. So we don't need this. That was just to motivate why I'm writing 0 under here. Now, I know one thing. If you subtract 2 quantities and you get 0, you can write down the 2 quantities and put horizontal lines between them. Of course, they're equal. And if you have 2c2 plus c3 is 0, if you add 2 quantities and you get 0, then they differ by signs. If this is c3, then that must be negative c3. Or just bring that to the other side. c3 is negative c2. Okay, now when you come to your answer, which I have here in the blue, you should update this. Instead of c4, put 2 c1s. So in the first top equation, I see c4. So you know what? I'm going to put 2 c1. That's the only place in that blue box I see c4. Now I see c3 as well. I see it right there. So instead of positive c3, just remember, there's a plus sign in front. Those 2 horizontal lines say, wherever I see plus c3, I can put that. I can put negative 2c2. Negative 2c2. And multiplying the 2 in the blue by the negative 2c2, you get negative 4c2. I wrote x and g only using c1 and c2. x1 uses c1 and c2 only as constants, and y only uses c1 and c2 as a constant. That finishes that problem. This new problem is d squared x minus dy is equal to t, and d plus 3 on x plus d plus 3 on y equal to 2. Let us get rid of what's in front of y. We have dy and d plus 3y. You want them to look exactly the same, but you can't erase stuff. Well, down here I see a d plus 3. They both have y's, that's good. Down here I see a d plus 3, but on top I don't. So I put a d plus 3 on top. Now everything in the bottom is in the top. Now we reverse the game. Is everything in the top and the bottom? Well, the bottom has a d plus 3. It has a y, but it doesn't have a d. So I'll put a d in the bottom. Now, this and this, they look exactly the same. I'm going to eliminate the y by doing d plus 3 to both sides of the first equation. I do d plus 3 on that, minus d plus 3 on that, and I do d plus 3 on t, which will be 3t plus 1. If the derivative of t is 1 plus 3t is 3t. Of course, addition omits. It's 3t plus 1. In the bottom, I do d. I do d on this, plus I do d on that, and I do d on 2. That is, I take the derivative of 2, which of course is 0. Now, these two only differ by a sign. And if I want it to cancel out, I better add. So I add both equations. I'll have d plus 3, d squared. That is, I'll have this plus this, and I'm factoring out this. I have d plus 3d squared plus d plus 3. So this operates on x, and I add the right sides. I get 3t plus 1. I have d cubed plus 3d squared plus 3d squared plus another d squared. I'll have 4d squared plus 3d. This operates on x, and I get 3t plus 1. To solve the homogeneous, I just write down the auxiliary equation. That m cubed plus 4m squared plus n is 0. And factor out an m squared plus 4m plus 1. I do have one of my famous typos, should be 3m. And I factor out an m, but m squared plus 4n plus 3 is 0. And since that's an understood m1n squared, I can play, or try to play the n followed by number game times n followed by number game. Two numbers are multiply out to 3 but add up to 4, or plus 3 and plus 1. So either that's 0, and that occurs when n is 0, or n plus 3 is 0, which happens when n is negative 3. If you add two numbers and you get 0, the two numbers have to differ by signs. 3 is positive 3. So n must be negative 3. That 1 is positive 1. If you're adding two numbers and you're getting 0, if this number is 1, then that number, which is called n, must be negative 1. So let's see, x homogeneous must be c1 e to the 0x, but e to the 0x is 0, and e to the 0 is 1. You get c1 times 1, which is c1, plus c2e to the negative 3x, plus c3e to the negative 1x, or negative x. So that is the homogeneous solution. c1 plus c2e to the negative 3x plus c3e to the negative x. And we got rid of y. Now we are going to get rid of x. Down to get rid of x. Going to get rid of x. So we have d squared x. We have d plus 3x. Everything in the bottom should be in the top. When I see an x in the bottom, I have it in the top. I see a d plus 3 in the bottom, but I don't see it in the top. So I put it in the top. And everything in the bottom is in the top. Now we reverse the game. Is everything in the top and the bottom? Well, d plus 3 is in the top, it's in the bottom. D squared is in the top, it's not in the bottom. Okay, we'll put it. X is in the top and it's in the bottom. We're done. We do d plus 3 to the top equation and d squared to the bottom equation. So I do d plus 3 to this term minus, I do d plus 3 to this term. That's where I got my minus from. And I do d plus 3 to the t. Derivative of t is 1 plus 3t, or 3t plus 1. And for the bottom equation, I do d squared to both sides. I'll do d squared to this term plus d squared to that term plus d squared to that term. And when you do take the second derivative of 2, you get 0. Now, these two terms are exactly the same. So I subtract. Get rid of my side work. Now I'm going to do the bottom minus the top. If that really bothers you, well then put this on top. The reason I put it on top is, yes, when I subtract, this cancels out. But I hate negatives. I'm going to have this. I'm going to factor out that y. I have this. If you minus a negative, it's going to become plus d plus 3d. And this all operates on y. And I subtract the right hand side. Negative 3t minus 1. So I get d cubed plus 3d squared plus another d squared plus 4d squared plus 3d. This operates on y, and I get this mess. So I have m cubed plus 4m squared plus 3m is 0. But these are the same, this is the same equation we had before. So y homogeneous is going to be exactly like exactly like x homogeneous. But instead of using C1, C2, and C3, I'll use C4 plus C5e to the negative 3x plus C6e to the negative x. Just like it was there. Okay. So now we have, let me put it on top here, H homogeneous is C4 plus C5e to the negative 3x plus C6e to the negative x. Y homogeneous. C6. Now, what do we know? Okay, so some equations we had earlier, we had that d times d plus 3 times d plus 1 on x was 3t plus 1. That is distributing this out. You get d cubed plus 4d squared plus 3d on x is 3t plus 1. So we have x at the top. We have x is c1 plus c2 e to the negative 3x plus c3 e to the negative x. And we need up to the third derivative. X prime is negative 3c2 e to the negative 3x minus c3 e to the negative x. X double prime will be 9c2 e to the negative 3x plus c3 e to the negative x. And x cubed is negative 27c2 e to the negative 3x minus c3 e to the negative x. So I write down the third derivative of x, which is negative 27c2 e to the negative 3x minus c3 e to the negative x. And then I add on 4 times the second derivative. Add on 4 times that plus 36 e actually not true. Since we have x triple prime plus 4 times x double prime plus 3 times x prime is 3t plus 1, we should only guess what x is. It's going to be a polynomial. Say it's ax cubed plus at cubed plus bt, etc. at cubed plus bt squared plus ct plus b. And then the first derivative will be 3at squared plus 2bt plus c. The second derivative will be this, and the third derivative will be just 6a. Now I use this x triple prime plus 4 times this, the 12at squared plus 8bt plus 4c. Then I add on 3 times x prime. Oops. Enough of mistakes. They're all just careless, silly mistakes. X triple prime plus 4 double prime. That's double prime. Multiply it by 4. 24at plus 8b. Now I add on 3 times that. 9at squared plus 9at squared plus 6bt plus 3c. And this messes, well, I have 9at squared, and I have 24a plus 6bt's plus 6a plus 8b plus 3c is my constant. And this is supposed to equal to 3t plus 1, which is 0t squared plus 3t plus 1. So the 9a must be 0, which implies a is 0. The 24 plus 6b, the 24a plus 6b must be 3. It must be 3. Dividing by 3 to make the number smaller. 8a plus 2b is 1. And so a was 0, so then that must be 1. 8b plus 3c must be 1. Okay. Now, if a is 0, then b is a half. B is a half, and a is 0. And if b is a half, well then that's 4. 8 times half. Half of 4 is, half of 8 is 4. 4 plus this unknown number is 1. That must be negative 3. So C is negative 1. So now I can say what x is. X is 0t squared, or half 0t cubed, plus a half t squared minus t. Now we can say what x general is. That was x particular. The x general is 1/2 t squared minus t. X particular plus the homogeneous, plus c1 plus c2e to the negative 3x plus c3e to the negative x. That is x. Now, let us find out what y particular is. Y particular has the equivalent of this. It's going to have a little equation that had the y there. We got rid of x, and we just had y's. A differential operator on y. And we knew what it equals. Okay, that equation was d cubed plus 4d squared plus 3d on y is equal to negative 3t minus x. That is y triple prime plus 4 y double prime plus 3y prime is negative 3t minus. Let me write that a little higher to save a lot of space. Now this right hand side is just a polynomial. So we can pick a cubic, say. And we'll see if we were wrong by picking the cubic if it turns out that a has to be 0. So the general equation of a cubic equation. Now, I do want to comment on something. I'm almost certain that we solved for a, b, and c when we had x equal. When we had the x there, we solved for a, b, c, and d. And it turned out that x was 1/2 t squared minus t, because a was 0 and b was a half. Oops, these should be t's. Those should be t's. b was a half, and c was negative 1, and d was anything. So it really should have been plus d. But it turned out that in the homogeneous equation, we already had a constant, a pure constant. So we didn't need to write the plus d. And I suspect this may happen for y. So we'll get our hands dirty and find out. So I need the third derivative. So the first derivative, let's get rid of these old answers. The first derivative is going to be 3at squared plus 2b t plus c. And the second derivative will be 6at plus 2b. And here is the third derivative. So I have the third derivative. Put it right there. Third derivative. And I need to add on 4 times the second derivative. No mistakes here. That's the second derivative. And 4 times it will be that. I need to add on 3 times the derivative. 3 times this, which would be 9at squared plus 6bt plus 3c. And this is supposed to equal to what it says it equals to. Negative 3t minus 1. Now, the left-hand side, it has 9at squared. It has a number of t's. It has 24a plus 6b. How many t's we have? And then the constant is 6a plus 8b plus 3c. 6a plus 8b plus 3c. And this is equal to 0t squared minus 3t minus 1. So this coefficient is 0, this this coefficient is negative 3, and this coefficient is negative 1. So if 9a's are 0, that implies a is 0. So I really didn't need a cubic term. Okay. 24a plus 6b are negative 3. But a is 0. So 6b is negative 3. This means b is negative half. And 6a plus 8b plus 3c is negative 1. But that's 0. And 8b's is negative 4. Negative 4 plus some unknown number is negative 1. And negative 4 plus 3 is negative 1. Negative 4. Just add a few, write down a few numbers. Negative 4 plus what gives you negative 1? In fact, I didn't need that. I need to add 1, 2, 3. So 3c's must be 3. 3 times 1 is 3. So c is 1. Okay. So now I come back to my y equation and I plug in the a, b's, and c's. Y is 0 t cubed. B is negative a half t squared. And c is 1 plus 1t plus b. Well, that's 0. I don't need it. So y particular is negative a half t squared plus t plus an arbitrary constant. But that arbitrary constant is already in the homogeneous. So I'm okay there. So now y sub g is going to be negative a half t squared plus t plus the homogeneous part plus c4 plus c5 e to the negative 3x plus c6 e to the negative x. Let me write that a bit lower, please. Now, this is almost done. After doing all this, you're like, yes, I have y of t, and I have x of t, and I'm done. Nope. You have to get rid of some of these constants. You have to get rid of some of these constants. So you go back to one of the equations from 20 minutes ago. B squared x minus by is t. That is x double prime minus y prime is t. That's one equation. And the other one is b plus 3 on x plus b plus 3 on y is 2. That means the derivative of x plus 3x plus same thing with y. The derivative of y plus 3y is 2. Now, the big deal is, the big difference is here, we have to find the second derivative. On the bottom, we don't. But on the top, we need to find the second derivative and one first. And here we need to find both first and then multiply x and y by 3. We didn't have to multiply x and y by anything on the top. I think the second one is easy. X is 1/2 t squared. This is coming right from the bottom. So x prime will be t. 2 times a half, or half of 2 is 1 times t. Minus 1, constant leaves, minus 3 c2 e to the negative x minus c3 e to the negative x. That's x prime. X double prime. Derivative of that is 1. Derivative of that is 0. Let's not let it look like an x. Minus, and you bring down that 3, negative 3, it becomes positive 9c squared e to the negative 3x. Derivative of that is negative 1, so it becomes plus c3 e to the negative x. That's the second derivative. And what is y prime? Well, that's y. So y prime is going to be negative t plus 1. That 100% look like a negative t. Negative t plus 1. The derivative of c4 is 0. The derivative of that will be negative 3c5e to the negative 3x. The derivative of that will be negative c6e to the negative x. Now, if I multiply the left side by negative, I have to change all the signs. Okay. Now I add. When you add x prime and negative y prime, when you add x double prime and negative y prime, that's the same as x double prime minus y prime. And we were told that that's t. When we add the right side, we get t. The 1 minus the 1 cancels, and we get a multiple of e to the negative 3x's. We have 9c2 of them, and we're adding 3c5, plus we're getting a multiple of e to the negative x. We have c3 plus c6 of them. And the only way the left side and the right side are equal is they both have t. Everything else has to be 0 on the right side. This must be 0, and this must be 0. 9c2 plus c5 must be 0. Bringing that to the other side, we have 3c5 is negative 9c2. Dividing by 3, we have c5 is negative 3c2. And we also have that c3 plus c6 is 0. So c3 is negative c6. Okay, so we need to update our formulas at the very, very bottom with this information. We need to understand what those two horizontal lines mean. They have many, many meanings. One of the meanings is whenever you see that, you can write that. Whenever you see C5, those symbols mean you can write that. Well, I see C5 right there, right where I'm erasing. C5, positive C5 is negative 3C2 minus 3C2. That was C sub 4. And I see C sub 3 on the bottom. I see positive C sub 3 on the bottom. And whenever I see positive C sub 3, I am 100% allowed to put negative C sub 6 instead. That's their solution to this equation. Now, just for the record, we started off with C1, C2, C3, 4, C5, C6. We started off with those. Right now, the bottom equations, it has, I see C1 and C2, C1 and C2, another C2, and I see C4 and a couple of C6s. I got rid of only 2 of them. I didn't get rid of half of them. The reason is C1 and C4 were pure constants. Okay, they were just pure constants. C1, C4. Other than that, there were 4 left over, and I got rid of half of them. I'll get rid of half of them as long of only of the ones that are not purely constants. Okay, that finishes that problem.